Alright guys, here we go. Yeah. We're going to be looking at tangents and normals today. Now, I'm doing this video here in the middle of the Hong Kong airport. I think I finally found a place where people aren't going to look at me like I'm crazy because I'm talking to myself about math and derivatives and cool stuff like that. Or maybe they're going to look at me crazy anyway. Not that I care. Maybe I am kind of crazy. But anyway, we're going to go ahead and work on this. Now, as you can see on my title page, you already know everything you need to know about writing equations of tangents and normals. Now, what do you need to know? Well, you need to know that if I'm writing an equation for a tangent line, then I need the slope. Now, you already know how to get a slope because you get the slope from the derivative. Now, what else do you need to know? Well, you need to know that if a slope is tangent, then it has the same slope. And you learned that back in Algebra 1, that if something has the same slope, then it's going in the same direction. Therefore, in this case, it'll be tangent if it has the same slope and goes through the same point. All right, now normal, I thought that you learned back in Algebra 1, but apparently that's not a common term. Another word for normal is perpendicular. Okay, now hopefully you learned back in Algebra 1 that perpendicular lines are the negative reciprocal or the opposite reciprocal. Okay, so you just find the slope, you make it negative, you flip it, and that's the slope of your perpendicular or normal line. Okay, now other than that, you don't need anything else other than, I guess, maybe an equation to write a line, which you already know. You learned y equals mx plus b in the case of having the y-intercept. And you also learned another equation in algebra, which will be much more helpful, y minus y1 equals m times x minus x1. Now you're going to use this one more often, this one with the point slope, because this one doesn't require the y-intercept. You can use any point there for x1 and y1, and then you just put the slope in. If you want a tangent, you put the same slope in, and if you want a reciprocal, then, if you want a perpendicular and normal, then you put the negative reciprocal in for the slope. All right, here, let's just do one. You can see what I'm talking about. So here we go. Find the equation of the tangent to f of x equals x plus 1 over x at the point 1/2, 5/2. Now what does that mean? Okay, well that just means that I want a line that touches my graph. Now if it's going to touch it, not cross it, then it has to have the same slope as the graph does at that point. And then it needs to go through this particular point. So, thinking about my equation, y minus y1 equals m times x minus x1, right? I've already got a point, 1/2, 5/2. So that's my y1 and x1 here. What I still need, though, is the slope. So how do I get the slope? Well, you take the derivative. Woo, doggy. So we go take the derivative. Yeah, I just doggied in the middle of the airport, and I don't care. Okay, so we got x. We take the derivative of the x. Derivative of x is 1. Now, it'll be easier to take the derivative of 1 over x if you change it to an x to the negative first power. So we take the negative 1 and put it in front. Now, if we put it in front, then that means this will be a negative. So it'll be minus x to the negative 1 minus 1 would be negative 2. Okay, and then I'll go ahead and just rewrite this as f prime of x equals 1 minus 1 over x squared. Or you can leave it. It doesn't really matter. But anyway, we'll go on, and we now will find the slope at this particular point when x is 1/2. So I'm going to say f prime of x when x is 1/2 is 1 minus 1 over 1/2 squared. Now 1/2 squared is 1/2 times 1/2, which is 1/4, and 1 over 1/4 is simply 4. So 1 minus 4, which is negative 3. So I just got the slope. The slope of the graph at 1/2 is negative 3. So I can go ahead and throw all this into my equation now. And I've got y minus y1, which is 5/2, equals the slope, which is negative 3, times x minus x1. So that is a perfectly appropriate equation. Now, sometimes IB or somebody else may ask you to put it into function form, or it may ask for it to be in the form of fx, or just to isolate the y because that's kind of the standard format when you're writing an equation. So let's go ahead and do that just for good practice. We distribute the negative 3. So I got y minus 5 halves equals negative 3x plus 3 halves. And then we add the 5 halves to both sides, and we end up with y equals negative 3x plus 8 over 2, which is plus 4. And there's your equation.